Good day everyone, and welcome to the maths session again. We are still on the topic statistics, and we have started with the group data. We move to the group data, check how to calculate the mean, the median, the mode, the upper quartiles, lower quartiles, semi-interquartile range, and so on. But today we shall be looking at the graphical representation of data. There are many ways of representing data. One of them is the graphical representation. So I'd like you to come with me. Graphical representation of data. Just like it has been said, there are many ways of representing data graphically, but for the purpose of examination, we shall focus mainly on the bar chart, the pie chart, histogram, and cumulative frequency curve. All these charts are very, very essential, and they have their own different ways of representing data. So the first one we shall be examining is the bar chart. In the bar chart, we have rectangular bars of equal width. These bars are used to represent data, but while we are representing them, there must be spaces in between them. And we place the frequencies on the vertical axis, while the variables are always on the horizontal axis. We shall see how we draw bar charts and how to represent data on bar charts. So we shall examine an example to show how bar charts are drawn. This example says the number of crates of soft drinks sold to students of a high school on break time are as follows. So we have brands of soft drink and the frequency, that is the number of crates that was sold. So Coca-Cola, they sold 5 crates. For Pepsi Cola, we have 3 crates. Fanta, 4 crates. 7-Up, 2. Crush, 1. And Sprite, 2. The question is, draw a bar chart to display the data in the table above. So what we have to do is to draw a vertical line and an horizontal line. Join them to form a 90 degrees, like this. Since the highest frequency we have is 5, so it dictates the width of arranging my frequency and tells me how high I can go. So this is 5, the highest, and 1, the lowest. So I can use an interval of 1, that is, at every increase, this is, say, 2 centimeters represents 1 unit, then it increases by 1, up to 5. Then, with the brands of drinks that we have, put them, those are the variables, because they are different. For Coca-Cola, we have 5 crates. So you draw the bars this way and stop at 5. Make a rectangular bar this way and stop at 5, because we have just 5. Then for Pepsi Cola, here we draw it and stop at 3. Here. For Fanta, the same thing. Go up this way, stop at 4, because we have 4 crates of Fanta, and make a rectangular bar. Then 7-Up, 2, just like this. Make a rectangular bar for 7-Up. Crush is 1, so we go up to 1. And Sprite finally is 2. So we go this way and draw it. So the moment we have done that, we have represented the data in the bar chart. But note that there are spaces between the bars. This is for Coca-Cola. You leave space in between before you move to Pepsi Cola. He leaves the space in between for Fanta and so on. Very good question. I have a very good question here. And the question is there a specified width, or how wide should the rectangles be? And also, how wide should the space in between the bars be? When plotting this bar chart, we need a graph sheet. So when we are using the graph sheet has been arranged in such a way that we have spaces of 1 centimeter each. For some, 2 centimeter, but in the middle you always see the margin that is showing that this is from 1 centimeter to 1 centimeter. So it's better to leave a 1 centimeter space before drawing for the first one. Leave another 1 centimeter, draw the second one. So the second 1 centimeter will represent the width of this. Then the next one will be the space, so that the next one also will draw the rectangular bar, so that it will rhyme. Don't forget, earlier I said that the rectangular bars are equal, and they should have equal margins too. We have another question on bar chart. They could ask us to, they could give us a table, a frequency table, and ask us to present it using a bar chart. And we could also have a bar chart asking us to interpret the information that is depicting. So this question says, the bar chart below shows the pocket money received by students in a class in a week. Use the bar chart to answer the following questions. A. Find the total number of students in the class. We want us to find the total number of students in the class. So by looking at the bar chart, say that this represents the amount that the students are given or received, and this represents the frequency or the number of students. So if you look at this 250, it means it stops here at 4. So we have 4 students getting 250 naira. The next one, 300 naira, is in between 6 and 8. So if you follow the scale here, you have something like in the middle of 6 and 8. So if this is 6, the middle should be 7, and the next one should be 8. So we have 7 students received 300 naira. The next one, we have 6 here. So 6 students, 350. This one also, if you trace it down here, is in between 2 and 4. The 400 naira. This is 400 naira. So this is the height of the bar, and it's falling in the middle. So that's 3. We have 3 students getting 400 naira. So we move on to 450. We have 4 students there. Then 500, we have, this is between 10 and 12. So we have 11 students. Then the last one, 500, is just in the middle of 0 and 2, which is 1. So what do we do? What we have to do is just to add this together. 4 plus 7 plus 6 plus 2 plus 3 plus 11 for that plus 1. So that represents the number of students. And this means we have 34 students totally in the class. So find the total number of students in the class. Helps us to calculate from here by tracing it down. We have 4 plus 7 plus 6 plus 2 plus 3 plus 11, finally 1. The last question says, how many students received 300 naira or 500 naira for a week? Where we have 300 naira, we have 6 students. Okay, we have 7 students. 300 naira here, we have 7 students in between 6 and 8, and 500 naira, we have 11 students in between 10 and 11. So what we do is to add 7 plus 11, and that gives us 18 students. The third question says, present the information in a frequency table. Remember the first example, we had the frequency table and we were asked to draw the bar chart. But here, they have given us a bar chart. They said we should now, from this bar chart, get the frequency table. So what do we have to do? For 250, we have 4. So we just put it there. 4 number of students. We have 7 here, 6 here, we have 2 here, we have 3 here, and 11 here, we have 1 here. So this has been able to interpret this bar chart back to the frequency table. Now moving to pie chart. A pie chart is a circular chart divided into sectors. The angles are proportional to the magnitudes of their corresponding variables. So what I mean by variables are those measurements that we have. Since they are going to be different, it varies. I'm going to use this example to show us how to draw pie charts. But don't forget that I said it's a circular chart. This example said the table below is a breakdown of monthly expenditure of a salary earner. So expenditure and the amount. So rent, food, transport, clothes, and savings. So that means these are the things the person spends his money on. Part of it, 60 naira use it for rent, is 80 naira for food, 20 naira on transport, spent 40 naira on clothes, and saved 100 naira. The question is, draw a pie chart to display this data. The other one, bar charts, we were using bars, straight line, rectangular bars to represent our data, but here we must use angles. And for us to use angles, you need to remember that one complete revolution, which forms a circle, is 360 degrees. So how are we going to share these expenditures within 360? Because the whole of this is 360 degrees. So we want to divide this 360 degrees into parts. So how many degree will 16 naira take? What degree will 18 naira take on food, and so on? So the first thing to determine is to know the angle that is corresponding to each variable. Now we have rent. How do we get the angle? First thing is to sum the whole salary together. If we add this together, 60 plus 80, that is 140, plus 20, that is 160, this is 200, that is if you had 40, and 200 plus 100 gives us 300. So total salary is 300 naira. Now, for us to get the angle, 60 for rent. So for rent, the angle is 60 divided by the total, which is 300, multiplied by 360. So by dividing that, if you use 0 here, this 0 cancels this 0, 3 here 1, 3 here 2, 2 times 36 will give us 72. Then we simplify that. So for food, we have 80 divided by the total 300 multiplied by 360, since we are dividing the whole revolution into parts. By the time I divide this, 0 here, 0 here, this one, we have 96. For transport, 20 over 300 times 360, that gives us 24 degrees. on clothes, 40 over 300 multiplied by 360. That's equal to 48 degrees. And savings, finally, 100 divided by 300 times 360 gives us 120 degrees. Now if you note, if you add these angles together, it must give us 360. So we have succeeded in sharing the whole 360 degrees between the expenditures: rent, food, transport, clothes, and savings. So the next thing is to draw the pie chart and partition the angles, divide the angles for each corresponding expenditure. Now, the first thing is to draw a circle. It is better to draw our circle with a compass. If you put a compass in between the pointed mouth here, extend your pencil, it forms a circle. So by the time we form the circle, the pointed part will give us the center of the circle. So by locating the center, since we are starting with rent, we place a protractor like this at the center of the circle. So as long as we have that, draw a straight line. We draw a straight line. That's the radius. Radius of a circle is measured from the center of the circle to any part of the circumference. So radius can be drawn from here to the part of any part. So it could be anyhow. I'm just using this for my own interest. It does not have a specific way. You can draw your own down here, but you just know that you start measuring from there. So it's easy for me to measure with this. So 72 degrees. I place this here. This is 0. Try to make it a line. This is 0, so I count 10, 20, 30, 40, 50, 60, 70. Then the lines in between, this is 71, 72, 73, 74. The longer one is 75. So by the time we keep counting, we have 80. So 72 will stop somewhere here. And we join the angles. So this gives us 72 degrees. And we put rent there. The next one is food, 96 degrees. Now we have to start because we are going this way. So we have to bend our protractor this way so that we can count 96 from that line. This is 10, this is 10, 20, 30, 40, 50, 80, this is 90. We are going to 96. So 96 should be somewhere here. After 95, 96. So you just use something to demarcate that and join. So this is food. The next one is transport, 24 degrees. You can easily turn this way. Make sure you locate the center. So from that line, count 24. This is 0, 10, 20, 24, somewhere here. Transport. it's better to write it immediately after the division has been established, so that you won't make mistake. Then we have 48 degrees for clothes. So I start from here also. Make sure it is aligning with this. Put it at the center. Then count. 10, 20, 30, 40. Then this is 45, 46, 47, 48. Just put a dot there to help you. Then join. You join and stop at the circumference. It should not exceed the circumference. So this is clothes. Now, since the whole thing, we have 5 of them: rent, food, transport, clothes, and savings. And we have established 1, 2, 3, 4. The 5th one is automatically 120 degrees. So this will give us savings. Now I want to quickly show something here. If the question is like this, and they ask us the question, if this data is to be represented in a pie chart, what would be the sectorial angle for clothes? They might ask us that way. What would be the sectorial angle for clothes? We don't have to draw a pie chart in that case. What we just have to do is remember that clothes, the person spent 40 naira on clothes. So add the whole salary together, the amount, which is 300. Come here, 40 divided by 300 times 360. Get your answer, 48 degrees. That's all. They just want us to know, they just want to know the sectorial angle. They didn't say draw the pie chart because of time, so that we won't be wasting our time. It doesn't even carry any mark if we do that. Now we're moving to histogram. This is the third method of graphical representation of data that we are examining. So a histogram is a graphical display of frequency distribution. It consists of rectangular bars placed side by side. The variables are on the horizontal axis, while the frequencies are on the vertical axis. Now, a histogram looks like a bar chart, but it's not a bar chart. The difference between a bar chart and histogram is that instead of leaving spaces between, you have to close them together. You don't leave spaces between the bars when you are drawing histogram. But for bar chart, the bars must stand individually. So here, from the data, just use the idea that we used when we were drawing the bar chart. We have the example here. The table below shows a distribution of shoe sizes of 100 people. Size 39, we have 12 people having size 39. Size 40, 15 people. 41, 13. 42, 20. Size 43, 25. And size 44, 15. So that means we have 100 people. So the question is, construct a histogram for the distribution. So the first one, 39, starts here. Normally when you are plotting the graph, it starts from 0, 0. But in this case, you're starting from 39. Of course, we assume that this is actually 0, but it will not represent the correct spaces between them. So we can just put this to show that it's coming from a particular place. Now, 39, we have 12 as the frequency. So again, I like to talk about why I'm using 5, 10, 15 here. The other one we drew for bar charts, we had 1, 2, 3, up to 5. Here, if we start using 1, 2, 3, 4, 5, 6, 7, up to 25, even our graph sheet might not be enough, might not have enough space to contain that. So we have to draw it to scale. if you look at it, observe very well, we have 25 as the highest frequency and 12 as the lowest. Yet we can still move from 5, like just do 5 interval instead of 1, 2, 3, 4. It will be too big. Even 2, if we take 2, 4, 6, 8, 10, 12, 14, 16, 18, it will still not contain it. So we need to find a way to increase the scale. So if we take 5 first, then that is increased by 5 to represent 2 units or 1 unit, depending on what our graph looks like. So 0 to 5, this is 5, 10, 15, 20, 25, 30. At least this one will represent our data. That is the main reason. So as long as you have been able to represent the data we have, it's enough. So the next one is 39. Originally, people also have size 1, size 2, but here we are dealing with 39 to 44. So if I represent from 1, 2, 3, 4, 5, 6, 7, 8, 9, even before I get 39, I've exhausted the whole graph sheet. So that's why I put this to show that this is starting from somewhere, but these are the real parts that we need. So we have to start from 39. Even since if I put 1, 2, 3 up, it's not needed in this data. It will not even show any information. So I'm starting from here, and that is why I put this. So I really need this part. Now 39, 12 as the frequency. Just draw the rectangular bar, trace it. This is 10. So we count, it should be 11, 12, 13, 14, 15. So just count. And on our graph, it's easy for us to read that. There are small boxes to show us that, okay, the next one is 11, the next one is 12, 13, then 14, then 15. So this is 12. Then draw it from here, put the 39 in the middle. The next one, 15, size 40. 15 people have their shoe size as 40. So draw it close to it. You don't have to leave any space. So it must be standing side by side, straight up to 15. Or 15. So this is it. 15, and you draw the next one. The next one, 41 and 13. We have 13 should be a little bit above 12. That's why this one is higher a little, above 12. So this is it. Then 42, which is 20. 20 goes up here, stops at 20. Stops at 20, and we draw it beside it. Next one is 43 to 25. Draw it up beside it and increase this to 25. This is it. So you stop at 25 and you get it. The last one, 15. Shoe size is 44. Then we have 15 people. So 44, trace it back to 15 here. And we have that. So that's how to draw the histogram. But I want us to note one thing. That here, this is an ungrouped data presented in the frequency distribution. Just like the ungrouped data did earlier. So this is how to present it. Here, most of the questions they normally ask us from histogram is to find the mode. But in this case, even from the table, the whole mode is obvious. I said mode represents the number with the highest frequency. So that means the modal shoe size here is actually 43 because we have 25 people having the shoe size of 43. So we are going to examine the histogram using group data too. That will be the next example. Now, the next example we're going to examine is a group data question. So the table below represents the ages in years of 50 teachers in the school. So we have ages 21 to 25. Now they have been grouped. We have said this earlier that group data captures a group of numbers depending on what we are dealing with into classes. So these are 21 to 25. We have 7 of them are between age 21 to 25. 26 to 30, we have 11 teachers. 31 to 35, 9. 36 to 40, 9. 41 to 45, 6, and 46 to 58. So the question is, draw a histogram of the distribution. Number 2, use your histogram to estimate the mode. Use your histogram to estimate the mode. Now, when we are plotting histogram for a group data, it's important that we know that for group data, histogram is drawn with frequency on the vertical axis and class boundary on the horizontal axis. Different from the other example where we have to just put the values on the horizontal axis like that. But here we have a class interval. Some places too you use the class mark where we have to do this plus this divided by 2. But ideally it's better for us to use the class boundary. Now, how do I get the class boundary? Remember from what we have treated earlier that 21 subtract 0.5 gives us 20.5, then add the 0.5 to 25 gives us 25.5, and we keep going like that. 25.5 to 30.5, 30.5 to 35.5, 35.5 to 40.5, 40.5 to 45.5, 45.5 to 50.5. Just like I've said before, this helps us to increase the margin. And here, if you look at this, this is 21 to 25. And this one starts from 26 to 30. What about those who are between 25 and 26? So we need to create a boundary that will cater for that. So we now plot the frequency on the vertical axis and the class boundary from here on the horizontal axis. Alright, now we move on to plotting the histogram for the group data. Don't forget, this represents the ages, and this is the frequency, now the class boundary. The histogram for group data is plotted with frequency on the vertical axis, then the class boundary on the horizontal axis, starting from the first class boundary, 20.5 here, to the last one. So we have 20.5, the next one is 25.5, 30.5, 35.5, 40.5, 45.5, then 50.5. That is, start from the smallest to the highest. You notice that what we have here are also repeated here. So that is how to draw that. Then the next thing is to now start joining them. For this, we have 7. Now your 7 should cover the frequency 7. Then move from this place to this place. Don't forget, this is a whole class. 21 to 25, to 20.5 to 25.5. So this is a particular, this one represents the class. And the class should be from this to this. So the next class is falling on 11. So that should start from 25.5 to 30.5. So we start from here, draw it up to 11. This is 11. Extend the width and bring it down to 30.5. Then we move on. The next one, we have 30.5 to 35.5. This is 30.5. And we have 9 as the frequency. So you trace the 9 up to this place. This is it. Then you drop to 35.5. The next one is 9 also. That's why we have it like this. You draw the 9 also. For the frequency 9 here, trace it down to 40.5. Now the next one, we have the frequency at 6. From 40.5, this is 6. You see, this is 6. So down here, this is another class. Then the last one, 8. Draw it up to 8 here. 8. Then you stop and end it at 50.5. Then the next question is, the first question is for us to draw the histogram. And the next question is, from the histogram, estimate the mode. Now don't forget, during the class where we were talking about group data, I said the fact that we have gotten the modal class does not necessarily mean that we have gotten the mode. So obviously the modal class is 26 to 30 because it has the highest frequency. But this is just a class where the mode lies. But what is the mode exactly? That is the question. So since this is the class of the mode, because it's even the highest from here, look at it, that's the one with the highest rectangle. So this is how to locate the mode. The one that is closer to the highest one and the next one, this is it. Locate the highest one, the one before it, and the one after it. In the formula we used the other time, where we were saying that mode is equal to L plus delta 1 divided by delta 1 plus delta 2, where we were using the formulas with the class width. I said this delta 1 represents the frequency of the modal class, frequency of the modal class minus frequency before it. Then delta 2, frequency of the modal class, frequency of the modal class minus frequency after. So that's what this one is also showing us. This is the one before it, and this is the one after it. So we use it to get the mode. Now you trace a line here. Use a ruler for us to get it better. To trace the line from the edge here, then from here to now, wherever the two lines intersect, they intersect here, they are meeting at this point. So we trace it down to our curve. To the horizontal, trace it down to the horizontal axis. So you just keep tracing it until we get so on the horizontal axis, measuring the edges, this point is the mode, but we need to count. This is 25.5 to 30.5, meaning that the margin between this and this is 10. We subtract it. So that means the middle or the half of it, of this, will be, this is going to give us 26.5, 27.5, 28.5, 29.5, 30.5, just like that. Sorry, this is going to give us 5. The margin here is 5. 30.5 minus 25.5 is 5. So if we divide the 5 into average, 2.5, this one should fall somewhere. This is 26.5, 27.5, 28.5, 29.5, 30.5. This is just a rough estimate actually. But from the graph, it was obvious that the answer is 28.8 years. That's the mode. The last one that we are going to examine is the cumulative frequency curve. It is also known as ogive. So you can call it ogive or you call it the cumulative frequency curve. The cumulative frequency curve, I'm using this CFC as cumulative frequency curve, is a graph of cumulative frequency on the vertical axis against the upper class boundary on the horizontal axis. So if we want to plot a cumulative frequency curve, we need to present our table. Look at this example. The frequency distribution of the weight of 100 participants in a high jump competition is as shown below. So the weights, since it's a group data of 20 to 29, 10 participants are between 20 kg to 29 kg. 30 kg to 39 kg, we have 18 participants. Just like that, up to 70 to 79, we have just 9 of them. So, since we are going to be plotting a graph of the cumulative frequency against the class boundary, of course, the question comes this way, but we need to extend the table because we are going to be needing the cumulative frequency against the class boundary, the upper class boundary specifically. So, number of participants represents the frequency. So this weight in kilogram represents the class interval. Now, how do we get the cumulative frequency? Just like I said earlier, 10, you repeat the 10. So the next one, 10 plus 18 gives us 28. 28 plus 22 gives us 50. 50 plus 25, 75. 75 plus 16, 91. 91 plus 9, 100. Don't forget, I said we have 100 participants. So summation F also, the addition of the frequency should give us 100. So if we want to confirm if we have done the right thing, the last number here on the cumulative frequency column should be equal to the total number of frequencies. Then the class boundary. Now we have 20. For 20 here we have 19.5. Subtract 0.5 from 20, add it to 29 to give us 29.5. Just like that. So this is 29.5 to 39.5, 39.5 to 49.5, up to 69.5 to 79.5. Now we are going to have the vertical axis with cumulative frequency, then the horizontal axis, the upper class boundary. Don't forget, this is the lower class boundary and this is the upper class boundary. So we are going to use 29.5, 39.5, 49.5, 59.5, 69.5, up to 79.5. The upper class boundary is what we use for cumulative frequency curve. But for histogram, we started from this, the 19.5, the lower, to the highest one here, 79.5, just for histogram. But here, again, start from 29.5, 39.5, 49.5. So the next will be the cumulative frequency curve. This here is the cumulative frequency curve representing the data that was written earlier for the weights of participants in the high jump competition. Now, for us to plot that, I said we have the cumulative frequency on the vertical axis and the upper class boundary on the horizontal axis. You will notice that 10 is corresponding to 29.5 and the data. So what we just do is to locate that point and locate this. Draw this star. Then the next one is 35.5 on the upper class boundary with 28 on the cumulative frequency. So if you trace it, this is 20, you should have something like 21, 22, 23, 24, 25, up to 30. So 28 should be very close to 30. So you trace that 28, then 29, 39.5. Let's put this. This line was drawn after these points have been located. So we first locate the points, then we join the lines. So the next one we have 50, sorry, for 49.5. This is 50. Trace it down here, so we locate that point where they intersect. We have 75 for the next one. This is 70, this is 80, so 75 should be in between, and trace it down here. 69.5, that's 91, So 91 should be a little above 90. A little above 90, and you trace it to 69.5. And finally, 100. This is 100, and this is 79.5. So you locate that point. Then we can join the curve. From here, trace it, just trace it until it forms a curve. Now, this is a cumulative frequency curve. From our cumulative frequency curve, there are a lot of information that we can find out from it. So we have to find the median. We have to estimate the upper quartile, the lower quartile. We could also be asked to estimate the percentiles, probably the 50th percentile, 60th percentile, 75th percentile, anyone. So here we shall find out the median, the semi-interquartile range, and the 60th percentile. So that is, from the cumulative frequency curve, estimate the median, estimate the semi-interquartile range, and also the 60th percentile. So what do? We have done the calculation method of getting median, interquartile range, and so on from the group data. But now, from a graphical representation of data, we can also obtain those values. So there are times where they will ask us, from this set of data, draw the cumulative frequency curve. Then from your cumulative frequency curve, estimate the median, estimate the upper quartile or the lower quartile. So for the median, don't forget that median, we have n divided by 2, which is 100 divided by 2, and that is 50. So we locate 50 on the cumulative frequency axis, which is the vertical axis. This is 50. Trace it to the curve. Wherever it touches the curve, extend it downwards. So we say that from the curve, the median is 49.5. Then don't forget that median also is called Q2. So we can call this place Q2. The next one is the semi-interquartile range. The semi-interquartile range is Q3 minus Q1 divided by 2. So we need to estimate Q3, which is the upper quartile, Q1, which is the lower quartile. After getting the value, subtract it from each other, then divide it by 2. That will give us the semi-interquartile range. But for Q3, remember that we use 3n divided by 4. And that gives us 3 times 100 divided by 4. That is 300 over 4. And that's our position, which is the 75th position. Just like this is the 50th position. So trace 75 here. This is 60, this is 70. 75 is in between here. Just like we did earlier. This is 75, we have it exactly in between. So we trace it downwards. So Q3 is 59.5. Move on to Q1. The position is n over 4. Its position, which is 100 divided by 4. And that's 25th position. So we have, this is 10, this is 20, 25 in between 20 and 30. So we trace that also to the curve. Wherever it touches it, you stop there and trace it down. So this is Q1, this is Q3. Q1 from the curve, time you trace it very well, you see that it's almost is on this point we have 29, 30, 31, so very close to 39. You should have something like 37.5. So semi-interquartile range is equal to Q3, which is 59.5, minus Q1, which is 37.5, divided by 2. Okay. Now, the semi-interquartile range, just from this formula, Q3 minus Q1 divided by 2. So we located Q3 as 59.5 from this point. Then Q1 is here, 37.5. So it gives us 37.5 here. So semi-interquartile range, I'm using this semi-interquartile range. That will be 59.5 the Q3 from here, minus 37.5 the Q1. So this is it. Divided by 2, subtract this from this, we have 22 divided by 2. So our semi-interquartile range is 11. Then the last question, the 60th percentile. To get the 60th percentile, what we just have to do is do 60% of total. The total number of papers, which is 100. So we have 100 divided 100, so we have 60 here. Then we go back to the cumulative frequency curve. On the vertical axis, trace the 60, this is 60, trace it down to the curve, and trace it also back to the class boundary. So by the time we trace it here, we have 53.5. Just like I said, from 49.5 to 59.5, this is, the margin there is 10. So definitely the half of this rectangle, the half of this part is going to be average, that is 5. Divide 10 by 2. This one is not even close to that. So if I take it one by one, this will be 50.5, 51.5, 52.5, 53.5, 54.5, 55.5, just like that, up to 59.5. But on the graph, it should be easy to get because it is already scaled. This is just an estimate. Our answer is 53.5. So this 60th percentile represents this point. Q2 represents this point on the curve, and this Q1 represents 37.9 here. That's that.